All right, good morning. It is officially quiz time here at the Hunt household. There's my daughter Ellie. She's going to help us make a quiz, right, baby?
Make a quiz.
That's right. Okay, so we've been pondering physics here at the Hunt household, and one of the things we've done in the last couple days is we've constructed an urban slide. As you can see behind me here, we have the basement steps, and it makes a nice little ramp. We have a little piece of kind of plastic. That's a nice smooth transition on the bottom. And here we have this beautiful sledding device, and my daughter has been having lots of fun sitting in this and sledding down the steps. So what I thought we'd do today is an authentic physics problem where we figure out the coefficient of friction between the sled my daughter sits in and the stairs that she is sledding down. Right now she's destroying the tape measure. Here, let me have that, sweetie. We got to make a quiz. Here. All right, beautiful. So sorry about the terrible filmography, but we're just going to have to make do with what we got. So here's what we're going to do is I'm going to give, yeah, you're going to help me. I'm going to give the phone to my wife, and we're going to head upstairs, and we're going to actually collect some data for this quiz. And then we'll walk you through the data and some of the information, and I'll pose the questions to you, and you guys should be able to get started. Sound good? Okay, so I'll hand this over. All right, let's head up, Ellie. We're going to make a quiz. Come on. Yep, let's go. Let's go sled. All right, keep going. All the way up. Yeah, all the way up. Let's go. Good. All right, we're heading up. Yep. So what we're going to do is we're going to go to the top of the steps, and my daughter is going to sit in the sled. Come on, sweetie. You're in the way, by the way. All right, lay down. Lay down. Put your feet at the end. Okay, you ready? All right, in 3, 2, 1, go. Woohoo. All right, beautiful. So that is the situation. Again, well, hold on. We got to talk about this quiz first. That's right. So let's talk about some measurements you'll need. First off, hopefully my wife is still filming. My daughter weighs, let's see. I'm going to say about, how much do you weigh, Ellie? Maybe 32 pounds. So we're looking at 14 kilograms. 14 kilograms is the mass of my daughter in the sled. So that'll be some important information you'll need. We measured from the top of the steps to the bottom earlier. That was off camera. And we're roughly from top to bottom 5.2 meters. So that's your distance. We've done this a number of times. Yeah, we've done this a number of times, and we found out that it takes Ellie about 2.3 seconds to get from the top of the stairs to the bottom. So imagine that she starts from rest with an initial velocity of 0, and in a time of 2.3 seconds, she travels that 5.2 meters, okay? The angle of the steps is actually a pretty steep stairwell. We measured it at around 40 degrees. So when you're looking at an angle to deal with for the incline, 40 degrees is the angle you're going to look for. So I'll take the phone back now, and we'll kind of finish up the question. So here's what I want you guys to answer. Obviously, you have some motion equation information. You have, we're doing it, sweetie. We're making a quiz. You have the initial velocity. You have a time to get down the stairs. You have the length of the stairwell, and you have the angle of incline. So all that information is enough to plug into motion equations and get things that you might need. You also have the mass of my daughter and the sled that she was on. And so what I want you guys to do is for part A, I want you to draw a free body diagram of the scenario. So draw a free body diagram of basically Ellie and her sled and all the forces acting on them as they sled down the incline. Make sure you don't include me holding on to the sled. Just consider it right from release to when we reach the bottom, okay? And I realize we slow down and break at the end, and we're just focusing on the ramp part, so keep that in mind. So part A is draw a free body diagram and label all the forces acting on my daughter and her sled. Part two is find the weight of my daughter in the sled and find the components of the weight. So find my daughter's weight, not her mass, find her weight and the components of the weight. That's part B, okay? Find the weight and her components. Part C, here's part C, is calculate the acceleration. We're making one right here, baby. Calculate the, you want to sit with daddy and make it? Calculate the acceleration that my daughter experienced while sledding down the hill, okay? We want to calculate that acceleration. And my recommendation is we don't want to use forces for that. We probably want to use motion equations because of the information we're given. So we're kind of reverse engineering this problem. Part D is determine the normal force. All right, part D is determine the normal force acting on my daughter and the sled as they go down the hill. Part E is find the frictional force between the sled and the stairs. Okay, find the frictional force between the sled and the stairs. And then the last part is I want you to actually tell me what the coefficient of friction is between the stairs and the steps. Okay, so you should have all those parts. Again, it's draw a free body diagram. 2, find the weight and the components of the weight. 3, let me remember what 3 was. Find the acceleration, and the key is we use our motion equation information from that. You might have to rewind the video and watch different parts to list all those givens. D, find the normal force. E, find the frictional force. And then F, find me the coefficient of friction ultimately between the stairs and the sled. Sound good? Okay, so that is your quiz. The rules are I want you to write this out and do this on a blank sheet of paper, okay? You have until tomorrow night to finish this up. My request is that this is not something you work on with other people. I want you to do this by yourself. Obviously, I can't police that, but I'm trusting that you guys will, on the honor system, kind of make this, work on this on your own. Try not to use any outside resources, except unless you wanted to look up an equation, say for F equals ma, or say one of your motion equations, you're allowed to have that equation sheet with you. Please don't consult others for help. Please don't consult the internet for help. And please do this in one sitting. Don't go away and come back. Don't have your notes out and stuff while you do this. Now, you have all day today and all day tomorrow to complete this quiz. I'm going to put on the remind instructions to not watch this video until you have completed and submitted the friction homework, okay? So I want you to get that homework done first, and then after that homework is done, I want this quiz to kind of be the culmination of that. So if you're still having trouble with the homework, get on office hours today. Obviously, you won't be able to see this to know, but I'll post some reminders about that with some of those instructions. But you'll do this on a blank sheet of paper. You'll write it all out, show all your work, part A through F, and then you will submit this on the assignment that I've created in Schoology so I can then grade and evaluate you guys on how you're doing. Okay, hope you guys enjoyed this. We talk about physics being real life stuff and authentic. This is a great example of that, where you can actually take real life events and scenarios and do some force problems and solve for some actual information based off this. So I realize some of these measurements, like my daughter's weight, is a rough estimate, but they're pretty close to accurate. And obviously, whenever we measure it, we're always going to have some error. So I wouldn't worry about that too much. Sorry about the poor filming, and sorry about my daughter yelling, make a quiz in the background a million times. She was just really excited to make this quiz for you guys. Hope you enjoy this. If you have any questions, feel free to let me know. Bye-bye.